Alright, welcome back. This is Chapter 4, Part 2, okay, and this is all the aqueous solutions. And today we're going to talk about a few different types of reactions that you should be familiar with. We've talked about, back in Chapter 3, we talked about some of these common types of chemical reactions, such as the combination, the decomposition, and combustion reactions. And so now we're going to take a look at a few more chemical reactions that are pretty common. And if you remember back in Chapter 4, Part 1, we talked about how water dissolves ionic compounds and separates them. Right? They become solvated, which means they're surrounded by water molecules. And so for insoluble compounds, basically the attraction between the cation and the anion are just too great for water to be able to separate those ions apart. And so you end up forming a precipitate, and the precipitate falls out of solution. This is what we call a precipitation reaction. So in order to identify precipitation reactions, and to identify what the precipitate is, we can predict the combination of certain ions that will form these insoluble ionic solids based on solubility rules for ionic compounds in water. Okay? And so we can see that on this next slide. This is the same. Basically, we have two tables here. The first one's in a red box, the second one's down below. I will give you one of these on the exam. This one requires you to make sure that you know the different anions and cations. But to determine if a precipitate forms, when we mix these aqueous solutions of two strong electrolytes, we must note the ions present in that the reactants. Okay? And we can consider the possible cation and anion combinations, and then use these to match it up in these solubility rules to determine if these will result in an insoluble product. Okay, so you don't have to memorize these rules, but you should be familiar with them and know how to use it. Well, one type of a precipitation reaction and another common type of chemical reactions that we see is called an exchange reaction. This is also called a metathesis reaction, or more commonly a double displacement reaction. And these reactions just involve swapping the cation and anions from the reactants. Okay, so here in this first example you can see we have AX plus BY, and basically the A and the Y, you have the cation 1 and anion 2 basically combine to form AY, and then the cation from the second and the anion from the first combine to form BX. Okay, double displacement, basically you're just swapping the cations and anions. And so if you kind of use those rules, which are given here at the bottom of the slide, you can pretty much write and balance these equations. Okay, and you're going to use the solubility rules we just learned about in order to identify the precipitation or what the precipitant is in the reaction. Okay, so here is silver chloride. Okay, we would know that that's insoluble and that falls out of solution. So make sure you practice some of these and you're familiar with these reactions and how to write them. Well, when we write equations for reactions in aqueous solutions, we need to identify if the dissolved substances are molecules or ions. Okay? And we know that we have this molecular equation shown at the top, okay, which really just shows the complete chemical formula for the reactant and the products. So for example, here we see that we have lead nitrate plus potassium iodide forms lead iodide and potassium nitrate. Okay? But the molecular equation tells us nothing about their ionic character. The ionic equation actually shows all soluble strong electrolytes as ions. Okay? So anything that's soluble strong electrolyte is going to ionize. So here we have lead nitrate. It's an ionic compound. It ionizes to lead 2+ and nitrate. Okay? Same thing with potassium iodide. That's going to ionize as well. The lead iodide, though, is insoluble, right? It's a solid. And so it does not precipitate out into, or it does not, it does not ionize in solution, and so it stays as this solid, okay? It's not breaking up. The potassium nitrate is an ionic compound that is soluble, and it breaks up into potassium and nitrate. Alright, so it's important that any ions that appear on both sides of the complete ionic equation, which is what we're talking about here, okay, these are spectator ions. So here you can see that potassium is on both the product side and the reactant side, and so it's just a spectator ion. Okay, same with nitrate, same thing. And so we can write what's called the net ionic equation, which is only going to show the ions and molecules which are directly involved in the reaction. So you see that we can cross out everything that's on the same side, and we're left with our complete ionic equation. So in order to write the molecular, the ionic, and net ionic equation, you can follow these rules that I've listed on this slide, okay? And it's important that you can do this, all right? A lot of times you're going to be given some reaction that takes place. You're going to have to write what the complete molecular equation is, which means that you're going to have to identify how to write a double displacement reaction, and then write the ions that form, cross out what spectator ions, and then you get this final net ionic equation for the reaction. One last thing that you should note is shown up here at the top. So charge is conserved in a reaction, okay? And so the sum of the charges of the reactants must equal the sum of the products. You'll also notice that when these ionize, right, like for potassium iodide, when it ionizes, the coefficient in front goes with both the potassium and the iodide, right? Because we talked about how you have electrolytes and what that, how that transfers through. All right, so now we can turn to another topic, which is acids, bases, and another type of reaction called neutralization reactions. Okay, so if you remember back in project number 1, the first project you did, I'm sure you noticed that some of the chemicals and some of those household products do contain acids and bases. Okay, these acids and bases are just electrolytes, right? We talk about how acids basically will ionize in aqueous solutions to produce what's termed hydrogen ions. Okay, when we're talking about a hydrogen ion, it's this H+. Okay, H+ is just simply a proton. It does not have the electron. When we talk about hydrogen, hydrogen contains both a proton and electron, and therefore does not have this positive charge. We can also talk about two types of acids. There's monoprotic acids and diprotic acids. A monoprotic acid will ionize to form 1 proton per molecule of acid, while a diprotic acid will ionize to form 2 protons per molecule of acid. Okay? So only the first ionization in a diprotic acid, like sulfuric acid, is complete, meaning that basically all that hydrogen ion has been ionized. And the second dissociation is more of a mixture of the products and the reactants. Bases are going to be substances that actually accept these hydrogen ions or accept these protons, and when they are dissolved in water, they're going to produce hydroxide ions, which is OH-. Most bases contain this hydroxide ion, but not all, so you can usually tell them by, you have sodium hydroxide, potassium hydroxide, calcium hydroxide, usually some metal combined with the hydroxide. Kind of tells you that's a base, okay? But there are others. The one that you need to know is NH3, which is just ammonia. It's a very weak electrolyte because only about 1% will ionize to ammonium and hydroxide. And ammonium is NH4+. The last thing on this slide is table of strong acids and strong bases. You need to memorize. Okay, you need to know it. You need to be able to write the net ionic equations for those as well. And that kind of goes along with this identifying strong and weak electrolytes. We've talked about this before, but you should pretty much memorize table 4.3, which is pretty straightforward, that pretty much strong electrolytes are any ionic compound, strong acids, and strong bases. Okay, your weak electrolytes are going to be more your weak acids and weak bases, and non-electrolytes are like the molecular compounds that we talked about before. So we talked about precipitation reactions, which form an insoluble product, and we can talk about another common type, which is called this neutralization reaction. Okay, it's the mixture of an acid solution with a base solution, and there's really 3 simple rules that you should know and be able to apply. The first is probably the most important, which is a neutralization reaction involves an acid and a metal hydroxide, okay, to produce an ionic salt and water. Okay, and this salt is just some kind of ionic salt. It's not necessarily sodium chloride. And you'll notice that the net ionic equation for most of these ends up being H+ plus OH- gives H2O. The second rule for neutralization reactions is that sulfides react with acid to produce hydrogen sulfide gas. Okay, so pretty much anytime you see a sulfide reacting, you're going to form that hydrogen sulfide gas. And the third rule is that if you have a carbonate, like calcium carbonate, and or hydrocarbonate, you're going to produce carbon dioxide gas and water, as well as this salt. Okay, so if you remember those three rules, you should be able to handle most of these neutralization reactions. That should conclude Chapter 4, Part 2. We'll pick up with Part 3, talking about oxidation reduction reactions, and a few calculations that go along with that. That last video shouldn't take too much longer. So, see you then.